Welcome, everyone, to AURI Connect's Webinar Wednesday. It's part of AURI Connect's recurring online series featuring updates on the work that AURI is doing to foster long-term economic benefit for Minnesota through value-added agricultural products. I'm Dan Scogan, your host on Webinar Wednesdays. The AURI Connects program is hosted by the Agricultural Utilization Research Institute of Minnesota, with sponsorship from Bremer Bank and from Avisen Legal. This program aims to actively engage all participants in the food and ag industry to improve the competitiveness of producers, businesses, and entrepreneurs through the ongoing purposeful connection of resources and partners along the value chain, and to increase knowledge of opportunities, technologies, and trends. The Connects program meets the AURI mission to accelerate the expansion of the agricultural economy by empowering expanded uses and markets of agriculturally derived products. Now remember, this event is being recorded and archived and can be found at auri.org. You'll be muted during our presentations, but you can send us your written questions through the Q&A portal on your screen. Today, we'll be continuing with part 3 of a 4-part series on climate change opportunities for value-added agricultural businesses. Today's discussion will focus on the water conservation and efficiency in food and ag processing, as we learn about important and relevant developments in water conservation and efficiency for production agriculture, animal farming management, and commodity processing. Joining me today will be 3 presenters, starting with Warren Formo. Warren Formo serves as the Executive Director of the Minnesota Agricultural Water Resource Center, a coalition of 20 agricultural organizations formed to support the continued improvement of all agricultural production systems through research and education. The MAWRC is dedicated to improving water quality by building greater understanding of the economic and environmental effects of agricultural practices employed on Minnesota farms. Warren also writes a monthly column on water resource issues for the Farmer magazine. We'll also hear today from John Vainio. John is an engineer, and he joined Mintap in May of 2014 with a background in aeronautical and mechanical engineering. John is a senior engineer with Mintap at the University of Minnesota. In his 10 years at Mintap, he's focused on energy efficiency, water conservation, hazardous waste reduction, and wastewater treatment optimization. Also presenting and helping to moderate today is Alan Deering. Alan is the senior scientist in co-products at AURI, where he began his tenure over 15 years ago. In this position, he's in charge of managing client projects and co-product pilot plants, collecting and reporting on data related to applied research and product development, and presenting AURI's project initiatives at industry conferences as well as at tours. And since this is the third in a 4-part series, we wanted to get some context for this discussion, starting with comments today from AURI's Senior Director of Science and Technology, Luca Zullo. Luca, please get us started today, and welcome to AURI's Webinar Wednesday.
Thank you, Dan. So as Dan mentioned, this is part of a series where we are focused on climate change issues that are important to agriculture-related industry. And of course, water is a big component of that. Water has always been important in agricultural processing. Obviously, you don't have agriculture without water. And when you deal with agricultural commodities to be processed, often we have to deal with water, and handling water often is expensive, both from an energy perspective, whether it's for drying or whether for moving the water. So there's always been an incentive to optimize the water usage. I think that the changes in climate change is really pushing us to be even more cognizant about the fate of water and be efficient in using the water. And I just wanted to remind some basic statistics about water. We see water as a ubiquitous material, but is actually not as abundant especially that we might think, especially fresh water, which is what we're interested in. So I always find it interesting to remind that only 3%, or actually slightly less than 3% of all the water that exists in all on the planet is actually fresh, so available for our processes, for agriculture, and also for drinking. Only 97% of the water is actually in the ocean and is salty. Then of the small amount, 3%, only 30% of the 3% is actually easily, in water reservoir like aquifers, and only 1% is actually surface water. So and we know that both reservoirs and surface water are actually threatened in some region by climate change. Hence, that's why we think this is an important topic. It's always been an important topic, but today has a renewed importance. And we have invited our speakers to provide an overview of critical issues in water management and conservation that relates to agriculture. And with that, without further ado, I'll pass it to Warren.
All right. Well, thank you, Luca, for that introduction. And I also want to thank AURI for the invitation to be part of this very important conversation. And with that, I'll move right into my slides here. So what I want to talk today about is water conservation and efficiency efforts that are happening on Minnesota farms, some of which, as you'll hear, are very common, and others of which are really cutting edge and just beginning to be explored. First, I just want to touch on irrigation. The image on the left is an early example of a pivot irrigation system, and you can see the water kind of going up in the air. And in modern days, over the last 30 to 40 years, the system on the right has become much more common. Very simple difference, and you have to look closely, but notice that the transition means that these sprinklers are dropping the water basically right into the crop. And I apologize for that technology glitch there. But the systems on the right have become much more prevalent. And between those two systems, we're looking at about a 30% reduction in water use. Those low pressure systems that drop the water right into the crop use significantly less water. And so that's been happening over the last several decades. But if I can hold that slide a moment. The other interesting thing, and this is more cutting edge, is about the potential for recycling and using wastewater, treated wastewater, through these pivot systems to essentially use that water, use the nutrients that may be in it for crop production. Then I'll transition to livestock, and this is a set of pictures that essentially tell us about multiple use. It's important that we use water as many times as we can to reduce direct uses of all of these different water sources. So what this picture depicts, on the far left, you see what looks like maybe a radiator. What it is, it's a plate cooler or a heat exchanger. On these dairy farms, they're drawing water from a well, and that well water is relatively cold. Of course, milk comes out of the cow relatively warm, and one of the first tasks is to cool it. And so rather than putting that milk right in a bulk tank where electricity would be required to cool it, it's run through these plate coolers, heat exchangers, to begin the cooling process. So that water's being used without being affected and reducing energy use and water consumption on the farm. From there, the water would go to the upper right picture, and the cows would drink it. And of course, dairy cows are producing a liquid product in milk, and they do drink a lot of water. And so that's the second use of it. And then in some systems, the lower center picture depicts a manure flushing system in which the water is actually used to flush the manure out to the manure storage facility. And so that's the next use of it. And there's still another use we'll talk about as we get to how manure is managed and applied to fields. But before I get into that, I want to talk about the swine sector. Just like kids, when it's hot, pigs like to play with their waterers. And so what you see on the left is a traditional nipple style water that that pig is enjoying. And so you can see the water dripping. The change from that traditional nipple water into the cup style waters, which you see on the right, allows the reduction of about 25 to 30% in terms of how much water is being consumed by the pigs. And of course, that water is going to end up in the manure pit as part of the manure, and ultimately will be transported out to a field. So not entirely wasted. It's still part of the cycle, but it greatly reduces the cost because transporting manure out to the field, certainly the less water volume, the easier it is to manage that manure. So now a little bit about manure, and you can see there on the left, that depicts what is really a very modern, innovative technology, not widely applied yet in Minnesota, but it is being looked at. And what it involves is applying manure into a crop. And because it can be applied into a growing crop, it can also often be timed to use that water more efficiently and the nitrogen and other nutrients in it more efficiently, because you can get the timing of your application while the crop is growing. The photo on the right is the more traditional method of applying manure in the fall or early spring before the next crop is planted. And again, that water is being put into the soil. Typically, these systems will apply that manure about 6 to 8 inches below the soil surface, minimizes odor, minimizes nitrogen loss, and it also prevents evaporation, and that water will be in the soil and available for future crops. Then if we can move to the next slide. Just a little bit about some things that are on the horizon. Some of these are being researched now, but very cutting edge. And the first idea there, variable rate irrigation. We know that as soils vary across a field, not every type of soil needs the same amount of water. And so there are several farmers in Minnesota who are part of research projects to essentially vary the rate across the field as that pivot goes around. And it's very new technology, rather costly at this point. But our Minnesota Department of Agriculture has grants available to help farmers retrofit their center pivot systems to basically change pressures to change volume across the length of that center pivot. And then as it goes around, it's able to adjust the amount of water that's applied. Tremendous potential to save water, tremendous potential to make nitrogen efficiency better, and very cutting edge technology that we're rather excited about. The next one is a concept that's being researched in various places throughout the Midwest, and that's the idea of capturing drainage water, holding it in some sort of a basin or reservoir, and then using it later in the season. You know, in Minnesota, we talk a lot about averages, but this year has been a really good one to help us recognize that water may come in the form of rain or snow, but not always when we want it. There are places that had nearly their expected annual rainfall in a couple months back in the spring, but then turned very dry later. And so if we had a system that was plumbed so that we could reuse that drainage water, it solves several challenges. One is that drainage water is not going to be released downstream, where there might be concerns about hydrology or flooding or nitrate impacts downstream. If we can recycle it and put it right back on the same field later in the summer, we're more efficient. The crop yields will be better and will be improved, and the water cycle will be benefited as well. And I think one of the most interesting things is the potential to use nitrogen more efficiently by putting that often nitrate-rich water back onto the crop. I kind of mentioned this in-season manure application technology when I talked about that. There are also research projects going on here in Minnesota as the system I depicted, where with a drag line pipe, which delivers the manure from the storage system to the tractor to then the field. And that's certainly something that we want to see explored more. But there's also potential to, with the advances in liquid and solid manure separation, to take the liquid portion, which again, that's where a lot of your expense in transportation is and the cost of handling. And if that could be fed back to the crop, either through an irrigation system or through a sub-irrigation system, such as drip tape, to feed the crop in season when there's greater efficiency and utilization of that nitrogen in particular, I think this is a real important area of both research and demonstration to show farmers to show more farmers how it can be done. And I say that with caution because it's farmers that have showed us that this might work. And so essentially the challenge we have before us is how to quantify and kind of help them perfect it, and then help share the information with other farmers so that they can better utilize that practice. I know there are other ideas farmers are working on. I have only touched on a few here, and hopefully some in our audience may have ideas as well, and we can get into that in the Q&A section later. Much of what I've been talking about could be described as recycling or reusing, and there's also relationships into processing. In Minnesota is a great place to grow crops and livestock. It's also a great place to process those things further into value-added goods and foods and the like. And so our next speaker, John Vanyo, is going to talk about some of those things that are happening in the processing world to be more efficient with water. So John.
Excellent. Thank you so much, Warren. So hello, everyone. My name is John Vanyo. I'm actually a senior engineer with MnTap at the University of Minnesota. And my presentation today will be to share some industrial water conservation case studies. So before I hop into the case studies, I want to give you a little overview of MnTap. Not everyone here has heard of us. We, can be a well-kept secret, but we try to do good work. So our group is the Minnesota Technical Assistance Program. We're at the University of Minnesota. We're actually in this McNamara Alumni Center right now, pictured here. Our mission is strengthening Minnesota businesses by improving efficiency while saving money through energy, water, and waste prevention. So the maybe simpler explanation of our group is we work with industrial manufacturing facilities on process efficiency projects. So we basically, I break down what we do into three main cores. And so that's our technical assistance, our intern program, and special projects. And so for technical assistance, our team will provide one-on-one site visits to you and your team. Will basically come out, chat with you about process efficiency opportunities, and then do a site audit as well, where we can collect information on the various processes. And then we can take all of that back to our offices. We can do literature review, we can run calculations, and ultimately develop for you a nice recommendation letter summarizing these process efficiency opportunities and laying out what's the resource conservation value, what's the cost savings value for your company, and ultimately help you to build some justification to implement some of these solutions. The second core of what we do is our intern program. So every single summer, we hire a group of very talented science and engineering upper-level college students and place them on site in Minnesota businesses for 3 months over the summer. And they really take those 500 hours to dig into these resource conservation projects. We get some very, very talented students, and they're bright-eyed. They want to save the world. They want to help you make your business more efficient. They do some of our best work, and all three of the case studies I'm going to share with you today come from that intern program. And then the final core of what we do is our special projects. So we apply for competitive grants to allow us to do deeper dive looks into specific sectors. And so one of those sectors, for example, is food processing. You're going to see a couple of food processing examples, and those are basically possible because of these special project grants. And I also mentioned, I do work with wastewater treatment plants. So right now I'm working on one-on-one energy audits with wastewater plants, again, made possible through these special projects type of work. So with that, let's hop into the case studies. So this first one is with Great Lakes Coca-Cola. This facility is a bottling facility in Eagan, Minnesota. This was a 2021 MnTap intern project, and the site was very interested in exploring water conservation. So the first step for most of our water conservation intern projects is to have the intern put together a nice water map for the site. Our student developed the water map, and what we found is that the site gets water both from wells and from city water. And the well water specifically goes through these dual media tanks in order to get cleaned and purified so that it's very high quality for the bottling process. What we also learned through the mapping process is that those media filter tanks use quite a bit of water for a backwash process or for cleaning. So in order to make sure your filters stay clean, you basically need to make sure you're cleaning the filters. And so that's done through a backwash twice a week. And so what our intern was able to do is actually dig into that cleaning process and did the turbidity testing you can see in the graph on the right, and found that currently, or I guess previously I should say, the cleaning process lasted 25 minutes for this backwash. But after about 20 minutes, and realistically maybe even 15 minutes, that turbidity is very, very low and those filters were clean. And so this site decided to implement reducing their backwash timer from 25 minutes to 20 minutes, and in doing so saved over 1 million gallons per year. The next example I have for you is Acron anodizing. This is an example from this year, so I figured I'd get a current one in here. And this is a rinse water optimization project. So again, our student put together a water map for the site. Anodizing process, the whole idea is you're trying to get the correct surface finish, and Acron is making aluminum window parts. So they do that by dipping their parts into dip tanks. And the final tank in most of these types of processes is going to be a rinse. And so at this site, they had 15 rinse tanks. And in order to keep your rinse water clean and ensure that your part quality is good, you basically constantly send water through those rinse tanks and then overflow the excess water to drain. And so prior to the project, each of those tanks was flowing at about 2 GPM. And our student was basically noticed that this ended up to being a lot of water over the course of the year, did some lit review, did some calculations, and eventually purchased the company some flow restrictors to run some tests. And our student was able to find that a 50 to 70% reduction in flow, just depending on the tank, resulted in still having clean rinse water and very, very high quality parts. You can see the flow restrictors pictured on the right here. And they were relatively easy to install, pretty cool, and they read off the flow as well, which is a nice bonus. And so these were implemented this year already, and Acron is saving 6.6 million gallons of water per year by reducing this rinse water. The final example that I have for you today is with Heartland Corn Products. This is a project I believe it was from last year. Heartland is an ethanol and corn oil facility in Winthrop, Minnesota. And again, they wanted to do a water project. We set our student out to do a water map, and we found more water than ideal in the cooling tower. And not only that, you can see from the graphic on the right, there's a line there that says city limit. The company was actually given a limit on the amount of blowdown water they could have coming out of their cooling tower. And so they really wanted to reduce that. And so for folks who are less familiar with cooling towers, the whole idea is you're sending a bunch of water to this tower to evaporate. That evaporate is creating a cooling effect, which we can then use to cool a refrigeration line. And the idea is that's the hot end of the refrigeration line will remove a bunch of heat, and then the cold side of the refrigeration line can cool your freezers and coolers. However, when we're evaporating all this water, we're concentrating the minerals into that cooling loop. And if you just keep concentrating minerals, you're going to cause problems with the pipes. So that's why we have what's called a blowdown line, to basically just remove some of that concentrated water from the system so we can add fresh makeup to keep that mineral concentration in check. The issue is that the main way to reduce water in a cooling tower is you would reduce the blowdown, but to reduce the blowdown, you increase the cycles of concentration, and they were already kind of at their limit of minerals in that line. So what our student was able to find through the water mapping is that the company also had a source of reverse osmosis water. They were using it for another process, but they could divert it to their cooling tower. And in doing so, that meant that their new makeup water had a smaller concentration of minerals, which meant we could concentrate what was in the water to a higher cycles of concentration without actually adversely impacting their cooling loop. They brought the cycles of concentration up, they saved some water, they got below their city limit, and not only did they save some water, but the water savings actually at the end of the day ended up being over 15 million gallons of water per year. So this is another really, really cool water savings example. So that's kind of what I have in terms of a few just water conservation case studies from industry. I do want to kind of give a plug here. Those are all intern projects. And if you have any interest in hosting a MnTap intern for next summer, we're currently accepting applications. You can fill out an application on our website. And, these students, they do excellent work. This is a little picture of our students from this summer. But they all had excellent projects. By the end of their project, they put together a nice final report. They put together a nice presentation for your company. They also put a public presentation together to share just the great sustainability work your company's doing. So if this applies to you, please check this out. And that's kind of all I have. So I really appreciate the time given to me to speak here. Appreciate your attention, and we will continue on with the rest of the session.
Well, thank you, John, and nice examples on terrific water efficiency savings for these companies. And now what I'm going to focus on today, I'm taking a little twist, and it deals with water, but it's how to deal with water and moisture, which is a little different than a lot of the focus that we've touched on today. One of the initiatives that AURI participated in, or that we focused on, was drying and handling of food waste or agricultural processing waste. The reason we did this is because oftentimes to add value to a waste product, they contain high levels of moisture. So a couple of examples that you can see on the pictures below, you have wet distiller grains, that obviously has to be dry. You have wet beet pulp after processing and sugar extraction, that has to be dried, and various food processing waste that we see coming into our lab. And oftentimes drying can be a deciding factor of the amount of value that can be added to that product later on. So that was the goal, and that's kind of what I want to touch on a little bit today, what we did with that initiative. So first, identifying drying and dewatering technologies that remove water efficiently. And then here's the key thing that we based everything off of. The theoretical best performance you can get for evaporating water is 970 BTUs per pound of moisture removed. And I'll share that with you on the next slide. So that is the theoretical optimum you can do on evaporation. What's interesting to know is the common energy required by industry right now to remove a pound of moisture is oftentimes greater than 2,800 BTUs per pound. So there is a huge cost savings potential out there that exists with identifying new technologies that are improved. So I touched on the economics of drying. And this is just a little chart to show you it takes 80 calories per gram to move ice over to the liquid state, over to water. Well, what we're looking at here when we're talking about thermally drying a product is how much energy, how many BTUs is required to evaporate that pound of water from the product. And you will see here on the bottom, I circled it. The theoretical best you can do is 970 BTUs per pound of moisture removed. So that's what we compared all these different drying technologies to when evaluating them. One of the key things, and before I give some examples of that, one of the key things to keep in mind, and we ran into this when we started to look at different drying technologies, is that, I shared with you the theoretical best optimum you can do for thermal drying, and that's at 970 BTUs. But remember, mechanical drying is always the most efficient. And we were running into drying technologies that had claims that were better than what they could optimally do. And what we learned, or what we found out, is there was a method of mechanical drying involved in that process. So just think of drying water in a sponge, whether you do it with heat or whether, and my picture shows, whether you're wringing it out with your fist, it always takes less energy to do it mechanically. So one of the things, the goal for AURI here, and the reason we did this initiative, is to move ideas to reality, and innovation requires implementation. So identify who has the technologies for our clients that we're working with to use to move this forward. And I'm just going to touch on a few of the drying examples that we pursued. one of the reasons we look at that, and I go back to the energy costs, I threw in one example here, and this was an example where we were actually pelleting dairy digester solids. So the digester solids came in at 63.7% moisture. And for us to pellet it or to do anything with it, we have to get it down to that 12 to 14% moisture. So that's a reduction of 50.5% moisture. So you can look at the math here. I won't go through it all, but that's within a ton of wet product. That's the need to basically eliminate or evaporate 1,151 pounds of water. So you can look at the math and look through the process. And I use $6 as a cost per million BTU for thermal drying. But at the end of the day, in that 1 ton of wet material, it would cost $11.05 to dry that ton, but that only leaves you with 848 pounds of product. So overall, drying costs for that to have a ton of dry product for us to work with is around $26 a ton. So that has a big influence on economics of adding value to either food processing waste or agricultural products that are high in moisture. So some of the interesting technologies that we looked at, here was one at a dairy in Wisconsin, and the Vandergeest Dairy, what they were actually doing is they were drying their digester solids to recycle them. They'd use the digester solids for bedding, but then they were also using the solids as a fuel source for their dryer. Very efficient, and it can work in multiple applications. But one thing you do need to be aware of is that you may give up about 50% of your dry product just as fuel. So that's something to take into account, plus the scale and the size of that dryer that's required. Another one we had evaluated was a rotary biomass dryer. We saw this up in Emily, Minnesota. This was actually being used on wood waste. The claim on this dryer was 750 BTU per pound of moisture removed. Obviously, that's under the theoretical optimum, but within this dryer, you actually had mechanical drying occurring, which act like a screw press to do some of the work for you. So it's interesting to see the different dryers and the technologies, and then follow up with their claims to see, can they hit it or how are they hitting it? Another one that we looked at was a Grow Tempest dryer. This was down in Iowa. You can see the claim down below, 710 BTU per pound of moisture. This one, and this was a portable unit. We used this for a demonstration that we did, but this involved, it wasn't just thermal drying, because you had some mechanical drying and improved surface area being exposed to drying, because they used a cyclone at high speed to move the material to improve their drying efficiency. Another one that maybe many of you have heard about is microwave drying, but on the industrial scale. And this is probably one of the more impressive systems that we were able to see. We saw this one down at the Beacon Center in Nevada, Iowa. There, we actually physically measured. We went down there, we took samples before and after. Here they were drying wet sugar beet pulp, and it was about 1,377, under 1,400 BTUs to evaporate a pound of moisture. So now when you compare that to where the industry is probably currently at for that material, you're reducing drying efficiency or improving efficiency by at least 50%. One of the issues that you will run into for microwave drying is the overhead cost. Usually this is a system you'd want to put in up front during construction. And then probably our most efficient system that we saw when you look at handling water, dealing with water, it's the Alga Ventures belt dryer system. This was down in Marysville, Ohio. This was actually designed to dry algae. Keep in mind, algae is high moisture. what you see on this product here is we took down thin stillage from an ethanol plant. So you're looking at a product that's probably 82 to 85% moisture. What you have here is a wicking belt. So the product is being lifted on a belt, and what you don't see underneath that belt is a counter belt to it, a wicking belt that's running opposite, pulling mechanically, pulling the moisture away from the solids. And by the end of the run, you're left with solids, very low energy input. It's basically a mechanically running belt and wicking. If you do want to speed up that process, they had shared that you can add thermal or heat underneath that belt that will speed up that process. It's going to add to the cost, but still very efficient because of the mechanical dewatering that's involved. So summary of what we found. Many dryers exist serving very unique feedstock. So obviously it depends on the feedstock you're drying to what type of dryer you're going to be pursuing or investigating. The belt wicking dryer obviously would not work for dairy digester solids, but more for aqueous solution. There are several systems that include additional claims, to lower their BTU content. And oftentimes, like I pointed out in the examples today, oftentimes it's going to have a form of mechanical dewatering going on with the thermal drying. The third thing, as I pointed out, mechanical dewatering is always the most efficient. It'll always be more efficient than thermal drying. And if there's ever an opportunity to reuse process heat, and I didn't have any examples of that today, but that's also a great way to improve energy efficiency. So a little bit different twist on looking at water conservation. I'm on the other end. How do you deal with excess water efficiently? But it's something we continue to see frequently here at AURI when we focus on adding value to, say, wet agricultural products or co-products. And I want to thank you for your time. Feel free to email or call if you have any questions. And Dan, I'll send it back to you.
Okay, Al, thank you. And also thanks to John and Warren. We've got some questions already in our Q&A portal. We'll get to those in just a moment. Warren, I wanted to circle back to you for just a second. If we'd all put our cameras and mics back on, I think we'll just have a little roundtable discussion here. Warren, typically are farmers coming to you and your organization, or are you out recruiting and trying to find new work?
It goes both ways. We do a lot of educational and, conferences, meetings with growers across the state. And that's really where we learn about some of their concerns and their interests and things that they're trying. And often it's just as simple as connecting. Maybe one farmer's trying something in a little different way. And by creating a forum or a conversation between them, they can learn from one another and innovate even more completely.
I was intrigued by one of your slides where they were knifing in the manure when the crop was up 6 or 8 inches. Is that labor intensive? It looked like it would be a lot of mechanical changeover at the end of each row.
Yeah, so actually there's a video online. That work was pioneered in Ohio, and it's not a cheap system, but essentially there's a reel that can roll up that hose, and at the end you turn, and the manure, the arm, the pipe that supplies the manure swings over, and so you drive back in the next pass. But while you're driving back, that pipe simply stays in the same row and rolls it back up. So it is more intensive. It's, and it's a more expensive technology. But, installing or applying manure in season has really been an interest of a lot of livestock farmers. I didn't have a picture of it, but we also know of farmers in Minnesota who are applying in season with tanker equipment where they can just go up and down the rows. But then there are concerns about, potential crop damage with those tires running too near the crops and that sort of thing. But certainly this whole area of using manure more efficiently and trying to address not just agronomic questions on the production side, but really some significant progress that could be made on the environmental side.
And we did have a question on websites. Do you have a favorite that you'd like to give out if people are looking for more information?
I guess I would go to the king of all websites, Google. If you've got a question, there's such a range of areas of interest and emphasis that I think there are a lot of great ones. Once you start down that path, I do think you need to be cautious. And, whether you're looking at industry or academic, university research sites, you got to be careful what you find. But I think in terms of getting introduced to concepts that can be helpful, new practices and the like, new technologies, I think so much of what farmers are doing today relies on really advanced technology that didn't exist 20 and 40 years ago. And so any of that information you can find online. But I would always start with just the basic research question you have and then go from there.
John, if I might, and Al and Luca, if you have some questions, feel free to jump in there too. But John, when a business comes to you or your interns, is there typically some low-hanging fruit that's pretty easy to pluck to get things started?
There often is, and to be honest, that's kind of where our group specializes. We really like looking for low and no cost opportunities, because just like what we found at MinTap is, there's always going to be an opportunity of, hey, buy this new piece of equipment. It's millions of dollars, but it'll save you money. But like, if we can find ways let's change your VFD speed, let's change your flow rate, let's reduce some of this cleaning time. Those are like the easier things to just get implemented now and can still have huge savings.
Do you have a website that you direct people to?
I do. The URL is mintap.umn.edu. Although I will say, I just tried typing that in and I got an error. So the workaround is, again, Google. If you Google Minnesota Technical Assistance Program, that first link will bring you right to our website.
And then we had a listener today that says, I want to know whether the institution can sponsor individuals who want to study or make research in agroecology at the PhD level. Is that something you do?
My little group at MinTap, I can't speak to that. The university as a whole, it's very possible. But I'm not the person to ask that one for.
We're going to circle around before we leave today and have everybody kind of weigh in on what they want to leave people with too. But Al, I'm going to come back to you because I know just through experience of spending some time with AURI and being in your co-products lab more than once, water is an issue all the time. You're usually trying to take it out, but sometimes in the pelleting process, you're trying to put some water or steam back in. And when you mechanically remove water, are you able to capture it and reuse it? Have you ever had a project like that or an initiative where you try to capture that water and use it again?
And I don't have an example of that, but Dan, you bring up a good point, and that's one that, because I'm aware of it, obviously we're working with various dairies, whether it's through digestion or with dairy solids and beddings. And I think one of the best examples of water reuse, and Warren had the slide on it, it's within those dairies. So we're not doing it in any of our facilities or with any of our clients, but the dairies that we work with, you're seeing a lot more water recycling. And that's where we're seeing it at, Dan.
And the mechanical dewatering you mentioned on several times is the most efficient, but you need the thermal to finish it. Is that kind of what happens?
Dan, and there was a whole set of slides that I didn't incorporate into this, but that's a great question because we did some work. This was with sugar beet pulp, looking at different mechanical drying methods. There's a lot of companies out there. And you're right, mechanical drying, and we have a Vincent screw press and screw presses here in the lab. you can take a product that's 82, 85% moisture, and that screw press can get you down to 65, 62. So the product will feel dry. You know, it's not dry because it's still holding on to moisture. And you're right, to get it down to that 15, 12, 10% moisture, it requires thermal drying. So some heat.
John, if you were to just speak to industrial business in general, why should they be talking to you? What are you going to offer them?
So the main selling point is really process efficiency, right? So the businesses that we work with, their main priority is to make their product and make a profit, right? They've got like a business focus. Our group can come in and help you with that efficiency focus of taking those processes that work, they're profitable, but we can help you to save resources, save money, and make those processes even more profitable. That's the simple explanation.
Is there a point where you let them go? Do they have that aha moment and then they're kind of on their own again? Or do you kind of continue to work with them? What's that process like?
Yeah, I mean, there's a little bit of that. So all of the work that we do with businesses, it's all no cost and it's all kind of at will. So folks can tell us, hey, like, we're done at any time, and it's all up to them to make the best choice for their business. But we basically just lay out for them in these nice recommendation letters, hey, here's the option available to you. Here's what we see in terms of resource conservation, cost effectiveness, and then it's kind of up to them to choose if they want to do it or not.
Oh, it's free of charge.
It's no cost, yeah, and confidential as well. I know I shared some examples, and those are all intern program projects that have already been presented elsewhere, but otherwise our general technical assistance is confidential, no cost, non-regulatory.
Warren, are you offering your services free of charge as well? I guess I didn't catch that in the presentation.
Yeah, so, we do a little bit of different types of research and basically technology transfer, sharing information with farmers. But yeah, our programs are funded by the Minnesota farm organizations that we work with through their membership and their checkoff programs. And so when we work with individual farmers or groups of farmers, it's free to that group to those farmers. And a lot of what we do involves either our own edge of field research to help figure out and build water budgets, help farmers be more efficient with water, or simply compiling our name, the Ag Water Resource Center. A lot of what we do involves finding research that either has been done in the past but is on a shelf and farmers need to know about it so they can apply it, or research that's being done in other states.
We do have a participant today who says, when this presentation is available online, I will be forwarding it to other groups that I'm involved with that also have a great concern with how we use water. Examples, he says, Freshwater Minneapolis, Rotary, among others. He says, knowledge is power. Apparently you've struck a nerve with this participant today. You've shared some information that he wants to share with others. And Don, we appreciate that comment from you today. If you have questions, you can put them on our Q&A portal. We'll certainly try to get them to them. Warren, you deal with irrigators. That was, I think, the first slide you showed. And there's different ways to run them. There's new technology that makes them more efficient. I see crops off now and they're running the irrigator on the stubble. What's happening there?
Yeah, so, first of all, I guess I should point out, I don't think I mentioned earlier, that in Minnesota, about 4% of our cropland is irrigated. So there are many counties where there is no irrigated cropland. Essentially, the ag that's there, it's predicated on high clay, fine textured soils that can hold water very well. Most of our irrigation is concentrated in just a few areas. And in those areas, it's a significant water user. And there are concerns about that water. I think in terms of helping farmers reduce water use, some of the tools that are becoming more common, it's as basic as weather forecasting, so that we're not irrigating when we don't need to, or if a rain is expected. That's the advances in weather prediction are important. But I think the other is just helping to share information about the newer technologies. As I said earlier, some of these are rather expensive and not really proved out yet in terms of return on investment. But I think that as they become more common And as farmers have more confidence in them, that will then hopefully the engineering and manufacturing of those systems will bring the cost down and make it more viable for more farmers. So we work with the Irrigators Association of Minnesota, with individual groups of growers, and basically help provide a network so that they can share information and be better at what they do.
John, you've done quite a bit of work and research with municipal plants. Economically, does it make sense generally to be hooked into a farm or a farm system where you can put some of that wastewater back out on the land?
It's interesting that you asked me from an economical perspective, because I haven't really studied that side of things. My best guess is yes, because most of the municipal wastewater operators really like partnering with farmers to share basically that free fertilizer with folks. But I haven't looked into the economics of it.
Al or Luca, what am I missing in this conversation? You both work with not only entrepreneurs, but industry and businesses on new products and processes around dewatering and watering. What else do we want to be thinking about?
Well, I think again, and the speakers have touched this topic. I mean, is really thinking about optimizing the use of water and the processing of water also forces us to think about slightly different about how we think about the processes. You know, like okay, how we do the drying. No, it's not only, and then and how we think about the drying not necessarily as an afterthought, but as a integrated part of the process. When looking at some of the work John has done, it's very interesting. Obviously, when you look at the consumption of water in cooling, you have, there is not only the blowdown, and you won't reduce the amount of wastewater going to the city, but also there is evaporative losses. So, there is, I think, you start seeing opportunities that, they have been known, but now they become more economical and more practical to change, for instance, going to air cooling in certain regions of the world. And we see more and more plants doing that in terms of additional air cooling. So I think, again, I think what we are seeing is that, and this is what we want to stress, is that start thinking about water, the issues of water and energy associated with water, integrally as a part of the process and not just as an afterthought, because the water is available, because there is a cost associated, increased cost associated with water, and if sustainability is important to your business, water is going to be increasingly part of that equation.
Al, you concur with that?
I do, and I had a couple other thoughts with that, Dan. One you had touched on, in southern Minnesota, you will see irrigation systems dealing with wastewater, excess water from processing facilities. Excellent opportunity to recycle those nutrients and benefit the crop underneath it. And then I thought it was very interesting what John shared, and this goes into economics in the example with Heartland Corn Products, where you could justify putting in that RO system to clean up their water to get it to meet the city's threshold. And I think those are all great ways to look at how do we improve our water handling, water efficiency, water use. So thanks, everyone.
John, where are we at with technology? Or maybe Warren wants this one, but we assume sometimes technology is getting better. Is it technology that's affordable and practical for practical use out on the farm?
Well, let me maybe start with, Alan's comment, I want to just make a quick correction. So
Sure.
I don't think it would have been cost effective for this site to put in a new RO system and start sending that to their cooling tower. They already had an RO system. They were using a portion of that water for another process, and they could send the rest of it over, and that was cost effective. So just to clarify there. In terms of technology, I mean, technologies are getting more efficient all the time. Things are getting better and better. I work a little bit more with industry and less with the farms, but I mean, I am sure that technology is getting better, and there are opportunities to upgrade, but also like trying to run what you have as long as you can is another form of source reduction and waste reduction.
Warren,
Yeah,
technology.
I guess I would just chime in at the farm level. I talk a lot very positively about technology, but that doesn't mean every technology is good and will work. Certainly there's a profit motive to developing technology and selling it as well. And so I think it's kind of buyer beware, that farmers have to vet and do some due diligence to make sure that these technologies might be useful to them and that they'll work and that the payoff will be there. But what I've seen in the last 20 years is just an incredible adoption of technologies on the farm that allow management decisions to be made based on actual information collected. 30 years ago, when yield maps and satellite technologies became available, there were farmers who thought, well, I know what my fields yield at the end. I haul it to the elevator, right? But then when they began to learn on a very site-specific basis how their yields were different across the field, it began a whole process of changing management in those different areas. And it's been hugely beneficial to agriculture. And so that's just an example. But again, the farmers do have to be careful as they're exploring these new ideas.
Question from one of our listeners today. Are there limitations to the size or scale of farms that you're all able to work with from a beginning or emerging farmer perspective? This sounds exciting, but also out of reach of many of our beginning scale-sized operations. Warren, is it too small sometimes?
I would have to say that sometimes there are, sort of a size limit where the technologies become possible. But I also see a lot of these technologies where they are size neutral and they can be employed everywhere. And what I encourage farmers, if you're of a smaller size, still explore those technologies larger farmers are using, because you can then learn how it's working for them and maybe innovate and figure out how to make it for you. And then the other option is, I know of many cases where farmers at a smaller scale, they would need a certain piece of equipment that's very expensive, and they share and work together. And so that can be another route. But no, I do get concerned if something becomes truly out of reach for any segment of the farming population. But I think for the most part, there are workarounds.
John, how about on the industry side? Does size matter when you start to do a project with somebody out of industry?
Yeah, I was going to say for farmers, I would send you over to Warren or Allen. But for industry, we can work with big or small as long as you're in the state of Minnesota. Our services are available to you.
Just a couple of minutes left in this webinar, so I'm going to go around the table real quick and let you guys have final thoughts, starting with you, John, since I've got you on the screen. What do you want to leave people with today?
I really appreciate the opportunity. It's a great opportunity to share with this group and to just chat and be part of this panel. It's really fun. We are currently scoping intern projects, so if you've got an industrial site interested in hosting an intern, now is a great time. I'm also trying to find some sites to work with for municipal wastewater plant energy audits. So, if you've got a wastewater plant in your town that could use a little looking and exploring on energy efficiency, have them give me a call. Thank you.
Thank you, John and Warren. Final comments from you?
Yeah, I would just echo what John said. I really appreciate being part of this discussion, especially like to learn more about what's happening on the processing side. And I would just say that I want to be encouraging to farmers as they explore ways to become more efficient. And for those who aren't involved directly in farming, who may have concerns about water use, my main message for them is that farmers take water quality, water issues very seriously, and recognize a lot of these issues and are working very hard to address them.
Allen, what do you want to leave us with?
I know we're running out of time, but the last thing, if you are in processing and looking at drying technologies, be sure to investigate the different technologies, have them demonstrate it, and pay close attention to the energy utilization, because there's a big variation.
And Luca, from AURI's perspective, how would you like to wrap this conversation up?
I would add that this is a critical topic for our activities, because all the agricultural processing involve water, and we remain committed to work with our clients and our technology providers to optimize water usage. And as Allen was mentioning, a lot of due diligence goes into it, and that is something that we are always open to do, and we see part of our mission to serve our constituencies, helping with these issues.
Thank you, Luca. Well, that concludes AURI Connect's Webinar Wednesday for today. I want to thank Warren Formo, John Vanyo, Alan Daring, and Luca Zullo for their participation today. AURI Connects Webinar Wednesday is presented by the Agricultural Utilization Research Institute of Minnesota and is sponsored by Bremer Bank and Avisen Legal. AURI's mission is to foster long-term economic benefit for Minnesota through value-added agricultural products and processes. And we're interested in your feedback, so please respond when we send you our event evaluations. Remember, for more information on today's program or any of the work that AURI is involved with, you can go to auri.org. This was part of part 3 of a 4-part series, so I invite you to join us on Wednesday, November 13th for part 4 in this series, when we discuss Minnesota's climate change opportunities for value-added agriculture around nitrogen. Remember, you can always learn more about other work that AURI is involved with by going online at auri.org.